So down there is the rotor stator of our bottom-driven float cell. There's an air line that's coming in for the cell, and there's a discharge line from the MACH reactor for when we precondition, and a very cool sight glass on the side where we can view the bubbles and we can view froth level and slime level, etc., etc. We also have a sampling point here for if you want to precondition with the MACH and maybe float in a different cell, or maybe you're doing a leach test, so you take it to a bottle roll. And this is the discharge line. This is the MACH reactor, and the discharge line from the MACH that feeds into the cell. And here's the suction line that's going down to a pump, which is housed behind these panels, which pumps back up underneath here into the MACH and then into the cell. So we recirculate on this float cell via the MACH reactor. This ring main is the air injection point into the MACH. So we're adding air to the MACH when we're operating using this rotameter, and then we add air to the cell separately afterwards for flotation. So let's talk about this control panel where we measure back pressure on the MACH reactor, and we aim for 7.5 or 8 bar. We can control that with this potentiometer for pump speed. That's sort of one of the most critical things we measure when we're operating. These two gauges give us the air pressure that's coming in, which I like to be above 5 bar, and at the moment they are perfectly around 6, I would assume, between 5 and 6 bar, which is great. And of course then the air rotameters are important for setting the correct air level to go into this MACH reactor, which is the smallest of its type in the whole world. It does only 0.45 cube an hour. So that's the MACH reactor from there to there. It has high-speed venturis built into it and a collection venturi built into it. It's an exact scaled-down model of a larger reactor. So there's no simulation in here. There's no compromise. The internals of this MACH is exactly the same as the units that do 3,000 cube an hour. So it's quite an achievement to have such a small test rig, and it is the only one of its type and kind in the world. We use it both for flotation and for leaching. You can use it for cyanide destruction tests. Actually, any test you want to conduct with a MACH reactor, you don't need to use this for flotation. It can be just a mixing vessel to do other work as well. We're opening up the suction valve to the pump. 850 micron pre-screen material. So it doesn't block up our 3mm high-speed venturis that are in the MACH. It's probably the most critical preparation step because we cannot have any oversized particles in here that will give us a problem on the unit. As I said, it is the smallest unit, so blockages is of a major concern to us. Is this PGM material?
Yes. Yeah. Oh.
Ground to P8075.
Yes.
Flat reef material.
Flat reef, yes.
So this is flat reef PGM feed material that we are going to precondition with the MACH. Will you add some reagents for us to get a bit of froth, Musa?
Yeah, we.
So we will do a flotation run on it so that you can see what it looks like when the MACH is in operation, and then also what it looks like when we are floating. So that's it. We've charged the cell now with the material that we would like to treat. You can see through the sight glass, you can get a good idea of the level. And that's the whole idea for the sight glass on the side, is so that the operators can see what level to run at. And that is the pulp level there. You can see we're almost bang on par with where it should be. And once we start floating and the bubbles start to form, it gets a little difficult to see that. So we're adding in collector at the moment, which is a xanthate collector. leaving it to precondition. You can see almost immediately there's a bit of mineral that floats up onto the froth. And by the color, it could be a copper mineral, could be chalcopyrite. So this metallic color you see on the bubbles there, I think that's either chalcopyrite or pentlandite or a mixture of them, that you get that nice metallic looking sheen. So this container is where we'll collect the product after we've preconditioned and done the float. So now we're putting in just a very little frother, and the reason to put the frother in is to make sure that we hold and retain some of the fine bubble that we're going to be creating with the MACH, because we don't want that all breaking up and dissipating. We're giving it a little bit of time to mix in. So now we have xanthate collector in there, and we have a little bit of frother, and it's conditioning. And we will be pretty shortly, we're going to start up the preconditioning of the MACH. And what we're going to be trying to do there is create a cavitation effect in the venturis of the MACH, so that we can nucleate the cavitation bubbles on very fine minerals, aggregate those minerals together as they go to a lower energy state when they're aggregated, and then we're able to float extremely fine mineral around 5 micron even. So Musa is now going to start up the pump, but before he does that, we'll open up the delivery valve, because we don't want to damage any of the piping or any of the measuring equipment. So we opened up the delivery to the MACH. We can see the pressure is at 0. Musa is now setting the air level, because before we start the MACH, we've got to have air running so that we don't damage or block up the air lines. And we are also just about ready to start. We're going to keep our eye on this gauge here, which is going to show us the slurry back pressure of the MACH reactor, and we're going to aim for around about 8 bar on that. So we are now ready to start. We have suction valve to the pump that's open, the delivery line from the MACH to the float cell that is open, the airflow to the MACH reactor which is on. So now we can hit start and let the magic begin. So that's the pump that's now started up. You see the pressure starting to build up, and we're achieving a good back pressure reading above 8 bar. The fine bubbles from the MACH are being discharged into the float cell, and you can see the agitation in the cell itself. So there is air going in to the MACH and an increased rate of agitation because we are circulating through the MACH reactor. You see some bubbles are starting to form already at the surface. You can see the metallic hue on those bubbles. So I reckon that there's some base metal flotation that's already starting to take place with this interaction inside the MACH. The length of time that we run the pump for is usually determined by the number of passes we are trying to achieve through the MACH. It's quite incredible to think that we have velocities in this MACH reactor that goes all the way up to 30 meters per second inside these venturis, the high-speed venturis, and very, very aggressive conditions that are created. So at the moment, all we are doing is we are recirculating on this float cell, which is like operating as a mixer at the moment, going down to the pump at the bottom and being pumped up to the reactor, back to the float cell. So we are just recirculating through the MACH reactor into the float cell to precondition, to create the cavitation, to form the pickle bubbles in advance before we start floating. Once we start floating, we will be collecting concentrate in this little bin. We run for about 10 minutes, 10 to 15 minutes, depending on how many passes we need. But you can see already that There's quite a lot of material that's starting to, you're good, you're covered. There's quite a lot of material starting to collect on the froth. That rich, dark, metallic hue, that's all the valuable mineral that we're trying to float. So now is when we are forming pickle bubble. When we are floating, we'll switch off the MACH and just float without it. So this is additional frother that we are adding in. It's going to create quite a lot of frothing and foaming. And you can see inside the cell, there's more bubbles starting to form already because we're putting more frother in. And we will open up the air to the cell in a minute, and you'll see this whole top section here where there's nothing at the moment is going to fill up with froth. So here we go. We're now opening the air. You see the froth building up, and it looks stunning, rich, beautiful. So this is concentrate now that we're pulling off. It will be high-grade PGM concentrate that we are floating off. So this is Mogalakwena ore, flat reef ore, with very, very fine-grained PGMs. That's normally very difficult to float, but it doesn't appear to be having any troubles floating here. So now we're going to be switching off the MACH reactor and floating without it to see what the difference is as we switch the MACH off. So we're going to leave the float cell then to do the flotation on its own. So there's the MACH off, and now we are just using the float cell for flotation. Is there a difference? I think there definitely is a difference. There's less bubble. There seems to be even less collection. The bubbles are more watery, breaking easier. This looks more like the tail end of a float. We'll switch the MACH on again in a minute to see whether we see a difference. So now we're going to switch the MACH back on to see what the difference is. Immediately I see a touch more color. There's a higher froth height, most definitely a higher froth height, and there seems to be more color, you can see, on the froth itself. Finer bubble, more of it, and better collection. The slime level, and you can see the froth that's building up above that. So that's the froth. From this point, of course, it's going up higher in the cell, but these are the fine bubbles that we're actually forming. You can see they are a lot finer here than they are on top. So I think the MACH is helping us contribute to that. We'll switch the MACH off again in a minute just to see what difference we see there as well. And let's see if we can see any difference in bubble size or in that collection. I think it's slightly larger bubbles already, but yeah, they are larger bubbles. You see those big darker rings, circles starting to form. We didn't have before. So the bubble sizes we're talking about are all under a millimeter anyway, so we're not going to really see with the naked eye what we're doing with the MACH. I think it's more visible. It's more visible on top. Switch the MACH on again, just for one last time, just to see that difference. We can see a watery froth, and immediately you switch it on, you can see the froth height picks up almost instantly. Getting darker already, a more stable, finer bubble in there, a lot darker immediately.